speaking about division of polynomial functions, and then two big theorems for this section called the factor theorem and the remainder theorem. All right, we're going to start off in example 2 here, and it says divide using long division. All right, so notice that this is a polynomial of 4 terms that is degree 3. So this is a cubic polynomial being divided by a linear because it's degree 1, linear binomial. A cubic polynomial being divided by a linear binomial. Now, what's very important is that you and I understand some vocabulary. What is being divided is the first polynomial. The first polynomial is being divided by the second polynomial. This is called the dividend, and it's being divided by the divisor. All right? What you get as an answer will be called your quotient. All right, here we go. Let's set this up. All right, using long division, I write my dividend underneath this division symbol, right? And the divisor is out here. Now, this is long division, and this is following the same format when you use long division for dividing just numbers. All right, so here we go. The first thing you're going to do is you're going to focus on the first term of your divisor and the first term of your dividend. And you're going to ask yourself this question. What do I multiply x by in order to get 2x cubed? X times something gives me 2x cubed. X times 2x squared gives me 2x cubed. So I'm going to write that up here. So it's x times 2x squared will give me 2x cubed. The next step in the process is to take each of these terms in your divisor, each term, multiply each one of them by 2x squared. And we're going to write the result, the product, down here. So x times 2x squared and 3 times 2x squared, and write the product here. All right, so let's do that now. So x times 2x squared is 2x cubed. And 3 times 2x squared is 6x squared. Now I am going to suggest a strong recommendation here, and the recommendation is that you use parentheses around the product that you just wrote, because the next step in the process is to subtract that product from your dividend. All right? So what you can do here is distribute this negative, right? Because really you're subtracting 2x cubed from 2x cubed. You're subtracting a positive 6x squared from 3x squared. To avoid making a sign error, I suggest you distribute this negative inside of here. When you distribute this negative, this becomes addition of negative 2x cubed and negative 6x squared. So like this. This becomes addition of negative 2x squared and negative 6x squared. Okay? I suggest you do this, that way you don't make a sign error. Now, something tells me I'm on the right track because 2x cubed plus negative 2x cubed gives me 0x cubed, so this is 0. That should happen each time. While 3x squared plus negative 6x squared is negative 3x squared. You see, if we did not distribute this negative right here, if we did not distribute the negative like I recommended, I'm afraid that some of us might write 3x squared plus 6x squared is positive 9x squared, which would be wrong, right? So you got to be very careful. This is really subtracting 6x squared from 3x squared. That's the reason why I'm having you use the parentheses and distribute the negative. That way we don't make a sign error. So this should be negative 3x squared. Bring down the next term in your dividend, okay? And then start the whole process over again. That is to say, focus on the first term of your divisor and this first term here. What do you multiply x by in order to get negative 3x squared? X times something, I'll write it right here, x times something gives me negative 3x squared. Well, that must be negative 3x. X times negative 3x gives me negative 3x squared. It's now time to take each term in my divisor and multiply each term by negative 3x. X times negative 3x is negative 3x squared. And positive 3 times negative 3x gives you negative 9x. I strongly recommend you put parentheses here, and then we have to subtract, right? So I suggest you distribute this negative, which makes it addition of positive 3x squared and positive 9x. Watch your signs. So I know I'm on the right track because this first column here adds to 0x squared, which is just 0. But here you get positive 3x, and bring down the last term in your dividend. Let me move up here. Okay. Now you start the process all over again, one more time. X times something gives me 3x. X times 3 will give me 3x. So that's what I write. Take now each term in your divisor and multiply each one of them by 3. So x times 3 is 3x, and 3 times 3 gives me 9. Don't forget that we are subtracting this product, right? Put parentheses, subtracting this product, which is the same as adding the opposite. So we're distributing, it's negative 3x and a negative 9. So then this is 5 minus 9, which is negative 4. Now, notice that the degree of your divisor, the degree is 1 because the power on that variable is 1. So this is degree 1. It's linear. It's degree 1. And this is a constant term. Any constant term has degree 0. Any constant term has degree 0. So your divisor is degree 1. Your remainder is degree 0. When you know you are done dividing when the difference here, or the remainder, is lesser degree than the divisor. This is degree 0. This is degree 1. Degree 0 is less than degree 1, so you're done dividing. You are done. All right, so let's write down our final answer. Let me come up here. Let me come up here to the original problem, okay? There. So our final answer is 2x squared. Let me write this down. So our final answer is 2x squared minus 3x plus 3 with a remainder of negative 4. So what I'll do is I'll put minus, and then 4 should be written, this remainder should be written as a fraction. So it's minus 4 over your divisor, which is x plus 3. All right, this is your final answer here. Okay, your final answer. I think I could fit it all. All right, now what's very important is that you understand this is your quotient. 2x squared minus 3x plus 3 is your quotient. Negative 4 is your remainder. So this is your quotient plus your remainder, which is negative 4 over the divisor. You always write your remainder, negative 4, you always write it over your divisor. Once again, we will use long division to divide this cubic trinomial by this linear binomial. All right, so here we go, same thing. So your dividend is 4x cubed. Now watch this. I need you to pay close attention here. Look at your dividend. It has a cubic term. This term is degree 3. This term here is degree 1. And then 3 is degree 0. Any constant term has degree 0. So this polynomial has degree 3, degree 1, degree 0. It's missing the second degree term. There is no term here that is being squared. Because of that, when I write my dividend, I'll write it as 4x cubed plus 0x squared minus 7x plus 3, okay? I know I can do that because 0 times x squared is just 0. Adding 0 to my polynomial does not change my polynomial, okay? So I'm going to do that. And the reason I'm doing that is because I want everything to be organized really neatly, and so I don't get confused, and that will do it for me. Everything will line up according to its like term. You'll see that now. All right, here we go. 2x minus 1 is my divisor. So I'm thinking now to myself, what do I multiply 2x by in order to get 4x cubed? If I multiply 2x by 2x squared, I will get 4x cubed. So 2x squared, right? Now this is the point at which I take each term in my divisor and multiply each of them by 2x squared. 2x times 2x squared gives me 4x cubed. Negative 1 times 2x squared gives me negative 2x squared. Remember that I suggest you put parentheses, and what we're going to do is we're going to subtract this difference from your dividend. Notice how this squared term is right underneath this squared term that I inserted, so things are lining up really neatly. If I had not written 0x squared, this negative 7x would be right here, and a first degree term and a second degree term are not like terms, so it'd be a big mess, right? And it would be easy to make a mistake. All right, distribute this negative, so it becomes addition of negative 4x cubed and positive 2x squared. Watch your signs. I know I'm doing something right because this sums to 0 right here, and this gives me 2x squared. Now, bring down the next term in your dividend and start the process all over again. 2x times what gives me 2x squared? 2x times x gives me 2x squared. So now take each term in your divisor and multiply each one of them by x. 2x times x is 2x squared. Negative 1 times x is negative x. I'll put parentheses around that right away, and I will subtract, and then I will distribute and add the opposite. Let me make that look like a plus sign a little better here. There. All right. So this is negative 2x squared and a positive 1x. So then I end up getting negative 6x. Bring down the positive 3. And then one more time, you guys. 2x times something gives me negative 6x. 2x times negative 3 gives me negative 6x. So that's what I'll write down here. And negative 1 times negative 3 gives me positive 3. I will subtract, distribute, and notice that your remainder is 0. That's very good. All right, so this is a cool example. I want you to notice a few things. First of all, this is your quotient. 2x squared plus x minus 3 is your quotient. Your remainder is 0. I want you to notice that your final answer, I'll write it right here. Actually, you know what I'm going to do is I'm going to scroll up here and use a brand new portion of the screen. This is what I want you to notice, which is really great about division, which is the reason why we're talking about division. All right. I want you to notice that 4... All right. Gosh. All right. Here we go. The dividend. 4x cubed minus 7x plus 3 divided by 2x minus 1 turned out to be, this is our quotient, 2x squared plus x minus 3. And then watch this, plus 0, but which is your remainder, but your remainder is just 0, so that's it. This is your dividend, this is your divisor, this is your quotient. Do you know that you can check division by using multiplication? So the way you check, and you can do this for each problem, including the one that we just did right before this one, you take your quotient, you multiply it by your divisor, then add your remainder, and this should give you the original dividend back. In other words, you'd be going in this direction. This quotient times this divisor plus your remainder, in this case is 0, should give you your dividend. All right, so it's going backwards, right? Using the inverse operation, the opposite of, or the inverse operation of division is multiplication. Okay, now this is the thing I want you to notice very carefully. If I take my quotient, 2x squared plus x minus 3, and I multiply it by my divisor, I get my dividend. Now you can do this on your own to verify, but it is correct, right? This does check out. But this is the part that I really, really want to highlight. I want you to take away from this lesson. We can use division to factor a polynomial. This polynomial, what we just figured out using division, is this polynomial factors like this. We didn't know that in the very beginning. This is how they gave us the problem. This polynomial divided by this polynomial is what was the question. You and I found the quotient. Now that you and I found the quotient, you and I know how this dividend factors. So division of polynomials is really helping us to factor a polynomial. Look at this. The left-hand side is the factored form of this polynomial. So really, the idea here, the strategy, what's really the reason why we're doing this in the first place is that this division is helping us factor a polynomial. Well, why do we care? Why do we care to factor a polynomial? So I'm glad that division helps me factor, but why do I care about factoring a polynomial in the first place? Well, if a polynomial is factored, I could then find the zeros of that polynomial fairly easily. Did you catch that? In the previous lesson, we were finding zeros of polynomials. So now I can see, if I can take a polynomial, use division to factor it, and then use the factored form of that polynomial to find the zeros of that function, well, there we go. There we have it. So that's the connection. That's the bigger picture here. All right, check out this next problem. You have a cubic polynomial, actually it's a cubic trinomial, being divided by a quadratic binomial. All right, so let's set this up. Notice that your dividend is out of order. It's degree 3 and then degree 0 and then up to degree 2. That's silly. So when I write my dividend out right now, I'll write it in the correct order. Correct order is descending power order. In other words, you start with the highest power and then you go down. In addition to that, notice that it's missing the first degree term. This is degree 3, degree 0, degree 2. There is no first degree term, so I'll insert that as I go. All right, so here we go. So x cubed and then minus 7x squared should be written next, plus 0x, since it's missing the first degree term, and then minus 8. And all of this is being divided by x squared plus 1. All right, here we go. X squared times x will give me x cubed. So that's how I start this. And then I multiply each term in my divisor by x. So x squared times x and 1 times x. All right. Okay, x squared times x is x cubed. And 1 times x is x. Okay, guys, I'm writing it over here so that my like terms are stacked on top of each other. I don't want to write x here because I can't add those two terms, all right, because they're not like terms. All right, here we go. Now put parentheses, and don't forget to subtract, and also don't forget to distribute that negative and add the opposite, so it's negative x cubed and negative x. What we get as a result is negative 7x squared, just by bringing that down, and then minus x, and then let's bring down this minus 8. Okay? Now keep going. X squared times negative 7 will give me negative 7x squared. So now I take each term in my divisor and multiply it by negative 7. X squared times negative 7 is negative 7x squared, and then 1 times negative 7 is negative 7. I put parentheses right away, and then I will subtract. And don't forget to be careful with your signs. Okay, I'll make sure that looks like a plus sign there. All right, cool. So then what you're left with is a negative x minus 1. Okay, now watch this. This is degree 1. The exponent is there. It's a degree 1 polynomial. Your divisor is degree 2. Because this is lesser degree, we are done. So our final answer can be written, let me move this up, okay? Your final answer can be written like this. Your quotient is x minus 7. Your remainder is negative x minus 1, okay? But the way you write your remainder is plus, and then your remainder over your divisor, like that. So there you have it, all right? Now, if you wanted to check, let me show you how you would check this answer. You would take your quotient, x minus 7, you would multiply it by your divisor, which is x squared plus 1. You would add your remainder, so you would do this arithmetic here. And once you do this distribution here, so distribute, and then you combine like terms, this should give you the dividend that you started out with in the very beginning. All right, so I'll just write this should give you, when you're done with this, so do all of that, and that should give you your dividend. Okay? All right, long division is long. That's why it's called long division. So it could be a little tedious and a little bit time consuming. There is a shorter way to divide. You're going to love it. It's called synthetic division. I don't know if you've done this before. If you have, then you'll remember that how short it is and how efficient it is. Now, you cannot always use synthetic division. We use synthetic division whenever the divisor is of this form, x plus c or x minus c. That is to say, the divisor must be a linear, degree 1, right? A linear binomial whose leading coefficient is just 1, okay? C, negative c, these are just real numbers, okay? So let's practice using synthetic division on this problem. Now, you and I did this problem already. I forget what the quotient is, but you can rewind the video to figure out to look at what we got for the answer. I think I remember the remainder being negative 4. That's all I remember. But anyway, we're going to do this problem again. We already did this problem using long division. Let's use synthetic division now. Notice that we can use synthetic division because the divisor is of the form x plus c. All right, here we go. You're going to think this is great. To get this started, what I'll do is what synthetic division does is it focuses only on the coefficients only. So the numerical parts, it drops all of the variables. So look at the coefficients of your dividend. 2, 3, negative 6, 5. 2, 3, negative 6, and 5. So that's the first thing I write down. 2, 3, negative 6, and 5. And then next, I write my divisor out here, right? I write my divisor out here. But I write down the number, the opposite of what I see here. So this is x plus 3, so I write down a negative 3, all right? Now, that's how so no variables or anything like that. The first thing I do is I bring down this 2 right here. I bring it down. So then that's 2. And then watch this pattern, okay? Watch the pattern. Multiply negative 3 times 2. That is negative 6. The next step in the process, now catch this. The next step in the process is to add. So 3 plus negative 6 is negative 3, okay? And then you repeat the process over and over again. So negative 3 times negative 3, positive 9. add. Negative 6 plus 9, 3. Negative 3 times 3, negative 9. Add. Negative 4. Many times I put a vertical bar here. This here is your quotient, and then this here is your remainder. Now, what's very important is the following, because I'm going to write down the answer. You're done. Look how short that is, guys. So it's all about getting down that pattern, right? Now, this is very important. Please hear me correctly or clearly. This is a degree 3 polynomial being divided by a degree 1 polynomial. Degree 3 divided by degree 1. Degree 3 divided by degree 1. 3 take away 1 is 2. Therefore, this quotient has 1 less degree than what you started out with. If you started out with degree 3, the quotient is degree 2. Did you catch that? The quotient is always going to be, when you use synthetic division, the quotient will always be 1 less degree than the dividend. So with that being said, these are the coefficients of your degree 2. It's degree 2 because that's 1 less degree than degree 3. So these are the coefficients of your degree 2 quotient. So it'll be 2x squared, right? Because this is degree 2. 2x squared minus 3x plus 3. That's your quotient. And then your remainder is negative 4. So we write that as negative 4 over your divisor. This is the same answer we got earlier in this lesson, this time around using synthetic division, which is way faster and more efficient. All right, let's do another problem. All right, let's divide this cubic trinomial by this linear binomial. Now, because this is of the form x minus c, I can use synthetic division. Now, of course, I'm going to use synthetic division whenever I can because I think it's a lot faster. All right, my coefficients in my dividend are, now watch this. Please notice that your dividend is missing a degree 2 term. Because it's missing the degree 2 term, I will insert a 0 for that coefficient. So the coefficients here for your dividend will be 1, that's your leading coefficient, 0 for the squared term that's not there, negative 7 for the first degree term, and a positive 9 for the constant term. It's very important that you put a 0 here. If you don't put a 0, it's gonna be all wrong. This 0 is for the squared term that is missing from your dividend. Now remember, the number that goes out here is the opposite of what you see in your divisor. So because you see x minus 2, I will put a positive 2 out front. All right, so let's use synthetic division. Do you remember the process? So the first thing is to bring down this first term here. So bring that down. I multiply. 2 times 1 is 2. I then add 0 plus 2 is 2. I multiply again. 2 times 2 is 4. I'll put 4 there. I add. Negative 7 plus 4 is negative 3. Multiply again. 2 times negative 3 is negative 6. And then you add 9 plus negative 6 is positive 3. Now, folks, this is your quotient, and then the number outside is your remainder. I'll just put a Q. This is your quotient. That was a weird place to put that. This is your quotient, and then this is your remainder. Okay, now watch this. I'm going to write down the final answer, okay? This is degree 3 being divided by degree 1, right? That means your quotient will be 1 less degree than the dividend. So then this must be a degree 2 or quadratic, all right? So it must be 1x squared plus 2x minus 3, and then your remainder will be written as plus 3 over your divisor, x minus 2. Isn't that great, you guys? Isn't that short, efficient, right? As long as you get the pattern down, you're good to go. Remember, though, that your divisor has to be of this form x plus c or x minus c in order to do this method. All right, next problem, x cubed minus 27 divided by x minus 3. Now, they just said divide. So I would rather use synthetic division over long division, so that's how I'll set this up. I can use synthetic division because this is of the form x minus c. Now notice that your dividend is missing a whole bunch of terms. You have your cubic term, you're missing a second degree term and a first degree term, and then you got your degree 0 term, right? So when I list out my coefficients, it'll be 1, that's the leading coefficient of my dividend, 0 for the missing square term, 0 for the first degree term that's missing, and then negative 27. And then out here, I'll write my the number that's associated with my divisor. Now remember, you take the opposite of what you see, so I'll do positive 3 here. All right? All right, here we go. So the first things first, bring down this number, right? Bring down the 1. So the 1 is there. Multiply. 3 times 1 is 3. Add. 0 plus 3 is 3. Multiply. 3 times 3 is 9. Add. 0 plus 9 is 9. Multiply. 3 times 9 is 27. Add. Negative 27 plus 27 is 0. All right? So again, this is your quotient. I'll just put a Q out here, a quotient, and then this is your remainder. Now, your quotient will be degree 2 because you started with degree 3. So your quotient is x squared, 1x squared, plus 3x plus 9 plus 0 for your remainder. Okay, so you're done. Isn't this fan? I hope you're a fan of this. Now, I want you to notice what we just figured out. We just figured out how x cubed, remember when I was talking about factoring, we just figured out how x cubed minus 27 factors. We just figured out we just figured out that x cubed minus 27, that's the dividend, is equal to x squared plus 3x plus 9 times x minus 3. This is the dividend, this is the quotient times the divisor. We just use synthetic division right now to factor this polynomial. All right, next example. Again, I'm going to prefer or opt to, I don't know why I wrote divide twice. Sorry about that. There. Okay. All right. So I'm going to opt to, I'm going to opt for synthetic division, and I can because this is of the correct form, x plus c. This is a mess. This is out of order. I'm going to write my coefficients in the correct order, which is descending power order. Also notice that you got degree 4, degree 4, degree 3, degree 2, you're missing degree 1, and then negative 7. So I'm going to write out my coefficients in descending power order. I will also insert a 0 when I get to the first degree term. Okay, the coefficient of my fourth degree term is 1. The coefficient of my third degree term is 1. The coefficient of my second degree term is negative 2. 0 for the first degree term that's missing, and then negative 7, which is my constant. And then the opposite of x plus 1, the opposite of plus 1 is negative 1. All right? Now, I will use synthetic division. I'll bring down the 1. I'll multiply. Negative 1 times 1, negative 1. I'll add 1 plus negative 1, 0. I'll multiply. Negative 1 times 0, 0. I'll add negative 2 plus 0, negative 2. I'll multiply. Negative 1 times negative 2, positive 2. I'll add 0 plus 2 is 2. And then finally, negative 1 times 2 is negative 2. For a remainder of negative 9. Okay, remember this on the left side is your quotient and the right is your remainder. Okay, now remember your quotient will be 1 less degree than your dividend. Your dividend, be careful, is not degree 3. Your dividend is degree 4 because that's out of order. So degree 4, that means your quotient will be 1 less than that, which is degree 3. So this will be 1x cubed plus 0x squared minus 2x plus 2 minus 9 over your divisor. You don't have to write this term because it says the coefficient is 0. So then you can write a better answer, x cubed minus 2x plus 2 minus 9 over the divisor. Okay, so this is your final answer. Now, I've been showing you how division of polynomials leads to the factorization of polynomials. So with that being said, let's end this lesson with the two important theorems, the factor theorem and the remainder theorem. The remainder theorem first. It says if a polynomial function f of x is divided by x minus c, then the remainder is given by f of c. So really what the remainder theorem says in and of itself is it basically gives us two different ways to evaluate a function at a value c. Here's an example. Let this polynomial be 2x cubed minus 7x squared minus 7x plus 12. Find f of 3. Now let me show you the old way we used to do it. Well, I shouldn't say old, just the traditional way for finding f of 3. We would plug 3 into the function, right everybody? So 2 times 3 cubed minus 7 times 3 squared minus 7 times 3 and then plus 12, right? And this is still fine. It's just that it is a lot of arithmetic. It's very easy to make a mistake. But it would be like this, right? Follow order of operations. There we have it. And so when you add all this together, you get negative 18. That's the answer, right? That's the evaluation for f of 3. Now, let me show you that the remainder theorem says that a polynomial function, when it's divided by x minus c, then the remainder is f of c. So if I use synthetic division, the remainder of my synthetic division will be the answer, will be the same as f of c. You're going to see that I can use synthetic division, and the remainder will be negative 18. So let me actually do this. Let me get rid of this for you, and then use synthetic division. Your coefficients are 2, negative 7, positive 12. 2, negative 7, positive 12. All right. And they gave you your c value. Remember, your c value, f of c, f of 3. So 3 is your value that you put right here. Don't put the opposite of 3, not in this context, because they already gave you the c value explicitly. All right. The factor, let me be clear about this. The factor is x minus 3, right? See, this is the factor x minus c that they mentioned in the theorem. The factor would be x minus 3. But what goes here is your c value. So positive 3, right? Positive 3. Or they gave you positive 3 explicitly. All right. So let's use synthetic division. Now watch this. I'm going to set this up for my remainder. Bring down the 2. 3 times 2 is 6. Negative 7 plus 6 is negative 1. 3 times negative 1 is negative 3. Negative 7 plus negative 3 is negative 10. 3 times negative 10 is negative 30. And this is negative 18. Look at that, everybody. What we just showed is that f of 3 is negative 18. And we use synthetic division. That's what the remainder theorem says. That if you use synthetic division, your remainder will be the same thing as taking 3 and plugging it into the function, right? The remainder is f of c. Check this out. They want us to evaluate this polynomial function at 1. Now the remainder theorem says that this evaluation, f of 1, will be the same thing as the remainder when you divide. So let's do that. Let's see, degree 3, degree 2, degree 1, degree 0. Okay, so we have everything accounted for. So 2, negative 7, negative 7, positive 12. And my C value is 1. Okay. All right, here we go. So my answer will be right here. My answer will be right here. Okay. So here we go, folks. So bring down the 2. 1 times 2 is 2. Negative 7 plus 2 is negative 5. 1 times negative 5 is negative 5. Negative 7 plus negative 5 is negative 12. 1 times negative 12 is negative 12. And there it is. That's the answer. F of 1 is 0. Now, we didn't introduce the remainder theorem just so that we would have another way to evaluate, another method to evaluate a function at a particular value. But the remainder theorem, along with the factor theorem that is now on the screen, together those two theorems will lead us or allow us to factor polynomial functions, which will then in turn help us find the zeros of those polynomial functions. All right, here comes the factor theorem. A polynomial function f of x has a factor of x minus c if and only if f of c is equal to 0. That is to say, when you use synthetic division, if you get a remainder of 0, that must mean x minus c is a factor for that function. Let's look at an example. In this example, they're asking us, is x minus 3 a factor of this polynomial? Well, the factor theorem says that it is a factor of this polynomial if and only if you're getting 0 as the remainder when you divide. So let's divide and check what the remainder is. If the remainder is 0, then the answer is yes. X minus 3 is a factor. If the remainder is not 0, then we can say no, x minus 3 is not a factor. Now we have to divide. How do you want to divide? Do you want to use long division or synthetic division? Yep, I'd rather use synthetic division as well. So look at your dividend here, right? This is your dividend. So your your coefficients are 2, negative 7, and 12. And this number that's on the outside, since they wrote it as a factor, right? They wrote it as a factor. Take the opposite of what you see because it's written as a factor. So positive 3. All right. Now, once again, everybody, if this remainder turns out to be 0, bingo. That means x minus 3 is a factor. If the remainder is not 0, x minus 3 is not a factor. That's what the factor theorem says. All right, so let's bring down the 2. 3 times 2 is 6. Negative 7 plus 6 is negative 1. 3 times negative 1 is negative 3. 7 plus negative 3 is negative 10. 3 times negative 10 is negative 30. And this is negative 18. All right, since the remainder is not 0, we know x minus 3 is not a factor of f of x. So this is using the remainder theorem and the factor theorem together. Let's look at another example. All right, another question. What about x minus 1? Is that a factor of this polynomial? All right, so let's do the same approach. Let's see. All right, remember, take the opposite of what you see right here because it's in factored form. So x minus 1 would be positive 1 out there, right? Now, remember, we are keeping our eye on the remainder. If the remainder is 0, then we can say x minus 1 is a factor. Bring down the 2. 1 times 2 is 2. Negative 7 plus 2 is negative 5. 1 times negative 5 is negative 5. 7 plus negative 5 is negative 12. 1 times negative 12 is negative 12. And we get 0. I don't know if you recognize it, but these last two examples we've done before. So anyway, here we go. 0. There we go. So what's our conclusion? our conclusion is the following. Since the remainder is 0, x minus 1 is a factor of f of x. All right, is x plus 1 a factor of this polynomial? Man, this polynomial looks pretty intense. Degree 4, and 1, 2, 3, 4, 5 terms, right? So I hope that you can see how the factor and remainder theorems are starting to help us factor a polynomial. If I asked you to factor this polynomial, that might be a really challenging task. I mean, this is 5 terms, a 5-term polynomial, and it's degree 4. How are you going to factor this polynomial? Might be challenging. But if you and I find that the remainder is 0, when I divide right now, then we know x plus 1 is a factor of this polynomial. All right, I always check to make sure I'm not missing any terms here. So degree 4, degree 3, degree 2, degree 1, degree 0. So we are good. So my coefficients are 6, negative 5, negative 23, negative 7, positive 5. And the number out here is negative 1. All right, so we're going to check out that remainder. Let's drop down 6. Negative 1 times 6 is negative 6. Negative 5 plus negative 6 is negative 11. Negative 1 times negative 11 is positive 11. Negative 23 plus 11 is negative 12. Negative 1 times negative 12 is positive 12. Negative 7 plus 12 is positive 5. Negative 1 times 5 is negative 5. Bingo, we got 0. Because we got 0, we know x plus 1 is a factor of this polynomial function. Fantastic. All right. All right, let's begin to wrap this up. I want you to notice that x minus 1 is a factor of this polynomial because when I show synthetic division, my remainder is 0. Let me show you that right now. All right, dropping the 2. 1 times 2 is 2. Negative 7 plus 2 is negative 5. 1 times negative 5 is negative 5. Negative 7 plus negative 5 is negative 12. 1 times negative 12 is negative 12. Remainder is 0, right? So we've done this already. So we know x minus 1 is a factor of this polynomial. Now, watch this. I want you to see the connection between division of polynomials, the remainder theorem, the factor theorem, all leads us to being able to factor a polynomial like this, all right? So this is what we know for sure. So f of x, which is equal to 2x cubed minus 7x squared minus 7x plus 12 is equal to, watch this, we know x minus 1 is a factor. Now watch this, x minus 1 is a factor times this quotient right here, right? Times this quotient. So really, this was my divisor, and this is my quotient. Remember, we were talking earlier. Now, this is your quotient. Now, remember, you started with degree 3. That means this is degree 2. So then it's 2x. Oh, I guess I should write in gray, huh? So then it's 2x squared minus 5x minus 12. So we were able to factor this polynomial by using division. And this is not a lot of work right here, everybody. So this is really great. Now, I can use my algebra techniques to factor this further as 2x and 1x right there. In order to get negative 5x, let's see, if we put minus 4 here and plus 3 here. Let's check. 2x times negative 4 is negative 8x. This is positive 3x. That would add up to negative 5x indeed. So this is the complete factorization of our polynomial function. How did we get that complete factorization? By starting out by using the factor, remainder theorem, and synthetic division. All right, you guys, this next example is really important. They want us to factor this cubic polynomial, completely factor it, given x plus 5 is a factor. Now, According to the factor theorem, if x plus 5 is a factor, that means when I use synthetic division with this factor, my remainder is 0. All right, so let's set this up. So these here are my coefficients of my function, 3, 14, negative 7, negative 10, right? I'm not missing any power, so degree 3, degree 2, degree 1, degree 0. So I don't have to insert any zeros. This is a factor. They told me that. So my C value is negative 5, the opposite of what I see. And I already know I'm going to get a 0 here. How do I know I'm going to get a 0? Because they're saying x plus 5 is a factor. All right, so drop down the 3. Negative 5 times 3 is negative 15. 14 plus negative 15 is negative 1. Negative 5 times negative 1 is positive 5. Negative 7 plus 5 is negative 2. Negative 5 times negative 2 is positive 10. Remainder 0. This doesn't surprise me. I was expecting that. But what I really, really wanted to get is this polynomial function, or this polynomial, which is degree 2. One less degree than what I started, right? So this is what I know for sure. F of x, which is equal to this, 3x cubed plus 14x squared minus 7x minus 10, factors as x plus 5, right? That was given to me. This factor was given to me. And now I know the next factor is right here, right? This is a degree 2 polynomial. So 3x squared minus 1x minus 2. Now the problem does say to completely factor, so I will continue factoring here using techniques from algebra. So I will set this up like this. Now it is possible that this quadratic does not factor further, okay? But I'm going to at least try to factor it further. All right, so 3x and x. I believe this has to be, let's see, my plus 2, and minus 1. Yeah, that'll be the correct factorization. This is the complete factorization for our polynomial function, and we use synthetic division, the factor and remainder theorems to find it. All right, last example. Completely factor this quartic polynomial function. Man, if they just stopped right there, I would be really challenged to do that. Like that sounds pretty challenging. It's a 5-term quartic polynomial. To factor that using my algebra techniques from earlier lessons, earlier courses, would be very challenging. But they give me some help. They're telling me that these two are factors. Okay, so I can use the factor theorem and the remainder theorem, and I can use that to help me factor this polynomial. All right, I'm setting this up. I do want to highlight or emphasize that I did check, degree 4, degree 3, degree 2, degree 1, degree 0. I'm not missing any powers of the variable. So because of that, I will not be inserting any zeros here. But be careful to make sure to do that check each time. Also, because this is a factor, -1 is the number that you put here. All right, here we go. So drop the 6. -1 times 6 is -6. -5 plus -6 is -11. -1 times -11 is +11. -23 plus 11 is -12. -1 times -12 is +12. -7 plus 12 is 5. -1 times 5 is -5. And then you got a 0 here. This did not surprise us because we already know x plus 1 is a factor. Now watch this, everybody. This is really great. This is your quotient. What degree is it? Well, if you started out with degree 4, this is now degree 3. All right, so let's drop the 6. 5 halves times 6. Don't let this throw you off here. 5 halves times 6. Remember, 6 is really over 1. And then cross cancel. 2 goes into 6 3 times. So it's really just equal to 5 times 3 over 1, which is just 15. All right, so this is 15. Negative 11 plus 15 is 4. And then 5 halves times 4 is 10. Negative 12 plus 10 is negative 2. And then 5 halves times negative 2 is negative 5. And I got 0. So I must have done something right. Now, this is very important. Let me move this up here. This is now degree what? You got it. Degree 2. I started out degree, let me move right back up. I started out degree 4 in the very beginning. And then once I divided, I ended up with degree 3. I divided again. That moves me down to degree 2, right? So these coefficients are really, really important, all right? So this is what we know. This is where I want to pick up. Our original function is here. It's this quartic polynomial. And they told us that x plus 1 is a factor. They told us that x minus 5 halves is a factor. And then watch this. Times, this is degree 2, so times 6x squared plus 4x minus 2. Look at that. Now, we can completely factor if we continue to factor this quadratic in here. To help us do that, factor out a GCF of 2 and put the 2 way out here in the front. Okay. All right, there's the 2. All right, so these factors were given. Now, when you factor out a 2 out of this trinomial, you get 3x squared plus 2x minus 1. Let's continue to factor. And now we're just using techniques from earlier algebra classes, right? And so, or earlier lessons. So this must factor as 3x and 1x. The signs must be different. This must be a plus 1 and then a minus 1, and that'll definitely give me that positive 2x that I need, because 3x times 1x is 3x times 1 is 3x. Negative 1 times x is negative 1x. That'll give us positive 2x. So look at this, everybody. This is the exciting part. This is fully factored. You and I were able to factor a quartic 5-term polynomial using synthetic division and a couple theorems known as the factor and remainder theorems. This is great news. And so this is the end of this lesson, but I just wanted to tie this into the lessons that are coming down the pike. So again, I said this earlier, but I of course don't mind repeating it again. The reason why we're so interested in using the remainder theorem, factor theorem, synthetic division, and long division to factor polynomial functions. The reason why we want to factor polynomial functions, the reason why this is so helpful to get this in factored form, is now you and I can find the zeros of this polynomial function. How? Well, you did that already in an earlier lesson. You take each factor, set it equal to 0, and solve. So factoring is a polynomial function that has been factored is super helpful when I need to find the zeros of that polynomial function. Okay? All right, everybody. Catch you later. Good job. I hope you learned a lot. I hope you find this very interesting as I do. Catch you later.